All right, problem number 13 on the world's largest learning guide. Okay, the asymptotes of a hyperbola are y minus 3 equals plus or minus 2 times x plus 4. From this, we need to remember a couple things. We need to remember that this is actually telling us from the asymptotes that the center is equal to the x value of negative 4 and the y value of positive 3, coming straight from that right there. All right, well, what else do we know? We know the foci are expressed as that. Notice that the y value is changing for the foci. The x value is staying the same, which is telling you that this hyperbola is oriented up and down. Also notice that the negative 4 is the same as the center negative 4, which tells me the 3, notice, is the same as the y value of the center. So, furthermore, I can determine that that square root of 5 is my c value. So c equals the square root of 5. And I want to get rid of those equal signs there. I don't like that. That is my center, is what I'm saying there. So c is the square root of 5. My hyperbola is vertically oriented, which tells me if I'm writing this equation, I'm going to end up with a y minus 3 squared term, and that's coming straight from that. Since this is up and down, that tells me that my y stuff needs to be positive. So it's going to be that over something minus my x stuff, x plus 4 squared over something as well, equals 1. And again, I know that my y term is positive because this parabola is going up and down. I said parabola again. I'll probably keep goofing that up. All right, what else do we know? Well, we know that this slope is in the form of either a over b or b over a. But since this parabola is up and down, that tells you that a is running up and down, which means it's a rise. So that 2 needs to be, remember it's a slope, rise over run. Our rise needs to be a over a run of b. And so we need to go ahead and think about what this means. Well, this means that 2 is in the form of a over b, which means that maybe the fraction's just 2 over 1. But how can we know for certain? Well, this would imply that a is 2 and b is 1. And this is a hyperbola, which means we need to have c squared equals a squared plus b squared. Again, note it's different than that of an ellipse. But c squared equals a squared plus b squared. So let's see if that works. Well, we know c is the square root of 5, so c squared is 5 equals a squared, 2 squared is 4, plus b squared, 1 squared is 1. So 5 is indeed equal to 4 plus 1, which tells me that that was the correct value of a and b. But remember, it could be any common multiple thereof. But there we go. We have a, b, and we have c, which means I can finish writing this equation as y minus 3 squared over my a squared term, so over 2 squared minus x plus 4 squared over 1 squared equals 1. And I have my equation in rectangular form. Well, what else do I want to do? Well, I want to write the equation in parametric form as well, and graph the hyperbola. So let's think about how we do this. So again, you're going to need to think of the Pythagorean identities. The most obvious one to remember is cosine squared plus sine squared equals 1. But this is not going to work as a substitution for this conic section because that is a minus, not a plus. And so what do we need to do? Well, we need to use one of the other identities. And so how do we do that? Well, let's divide everything by cosine squared. Right there. What do we get? We get 1 plus sine over cosine is tan, and it's all squared, equals 1 over cosine squared is secant squared. And let's rewrite this as 1 equals secant squared minus tangent squared. And that, squared right there, that does look to be in that form. And you should be able to recognize that, hey, that y minus 3 over 2, that's going to go to my secant. So we know that because the secant there is positive and the y here is positive. So that means that secant of theta is going to equal that expression y minus 3 over 2. Notice I've gotten rid of all of the squares. And let's solve this for y. So I need to multiply by 2. So 2 secant of theta, we'll get rid of that denominator of 2. Then I'll need to add 3. So 2 secant theta plus 3 equals y. And let's do the same thing with x. Since my tan term is the one that's negative, and my x term is the one that's negative, I'll make the substitution in a similar manner of x plus 4 over 1 equals tan. And then I will solve for x, which this time is actually pretty easy. And I can just say that x equals, sorry the sides are flipping here, x equals, I need to subtract 4, so tan of theta minus 4 equals x, and now I have my parametric equations. But again, I want you to compare this to the rectangular equation. For my y equation, notice that it was the same y equation essentially. The minus 3k turned into a plus 3, and the denominator of 2 squared turned into a multiplying by 2, and it's secant because secant is positive in our Pythag identity, and y is positive in this vertical hyperbola equation. Similarly for x. So there we have that. Last thing we need to do is sketch it. So to do so, let's draw our axes. We know our center is going to be at 1, 2, 3, 1, 2, 3, 4. Again, plucked straight from that. Except I totally just messed that up. Notice that the negative 4 is with the x, so that's telling me 1, 2, 3, 4, and the positive 3 is with the y, 1, 2, 3, my bad. So there's my center right there. Notice that with my y, I have that 2, and so that's telling me go up 2, and there's a point, down 2, there's another point on my box that I'm going to draw. And then with my x term, I have a 1 out front. That's telling me 1 to the right and 1 to the left. Boom, and now I can draw in that box like that, which lets me draw my asymptotes, which I'm too lazy to dash, but I usually draw them as dashed lines. They're my asymptotes right there, and I want to draw in this hyperbola. We determined it was vertical since y is positive, which means it's going to go vertically like that and down like that as well. And that vertex is actually on your box. Even if mine doesn't look like it, that vertex is on the box.